Hello everyone, and welcome to another video of the Mathmatecher channel. We would like to find out the limits of the function f in each of these three cases. So the first case is when the function f equals the polynomial minus x to the power of 4 plus 3 times x squared plus 7, and we have to calculate its limits when x heads to negative and positive infinity. And the second case is when the function f is a rational function that equals x squared plus 3 times x all over x plus 3, and we have to calculate its limits when x heads to negative and positive infinity, and the number minus 3, which are, by the way, the endpoints of its domain of definition. And finally, in the third case, when the function f equals the rational function x squared plus 3 minus 2 over x minus 4 all square, and we have to calculate its limits when x heads to negative and positive infinity, and the number 4. So let's start by the first case, which is the polynomial function. So, as for every polynomial function, the limit of our function f, when x heads to negative infinity, equals the limit of the term with the highest power, which is in this case, minus x to the power of 4, when x heads to negative infinity. And this limit equals negative infinity. As when x heads to positive infinity, the limit of our polynomial function equals also the limit of minus x to the power of 4, which equals negative infinity. Now let's move on to the second case. So in the case of a rational function, the limit of our function f, when x heads to negative infinity, equals the limit of the term of the highest power in its numerator, which is x squared, over the term of the highest power in its denominator, which is x. When x heads to negative infinity, and as these terms cancel out, it equals the limit of x, when x heads to negative infinity, that equals negative infinity. As when x heads to positive infinity, the limit of our rational function f equals also the limit of x squared over x, that cancel out to give us the limit of x, when x heads to positive infinity, that equals positive infinity. Now, when we try to calculate the limit of our function f, when x heads to minus 3, we find that it equals the limit of x squared plus 3 times x, which equals 0, over the limit of x plus 3, which equals also 0. Hence, this raised the case of an indeterminate form. So we will make an algebraical manipulation on our function f, by extracting the variable x as a common factor from the terms of its numerator to find that our function fx equals x times x plus 3, all over x plus 3, and by reducing this fraction, we find that fx equals x. Now, the limit of our function f, when x heads to minus 3, equals the limit of x, when x heads to minus 3, which equals minus 3. Let's now move on to the final case. So, as in this case, our function fx equals the sum of the polynomial x squared plus 3, and the rational function, minus 2, over x minus 4, all square. We notice that the limit of the fraction, minus 2, over x minus 4, all square, when x heads to negative infinity, equals 0. Hence, the limit of fx, when x heads to negative infinity, equals the limit of x squared plus 3, when x heads to negative infinity, which equals positive infinity. As when x heads to positive infinity, it also equals the limit of x squared plus 3, which equals positive infinity. Now for the limit of our function f, when x heads to 4. It equals the limit of x squared plus 3, when x heads to 4, which equals 19, minus 2, over the limit of x minus 4, all square, which approaches 0 from above, when x heads to 4, so the limit of fx, when x heads to 4, equals negative infinity. As always, thank you for watching the video. Give it a thumbs up and share it. Subscribe to the channel and activate the notification button for more. And until the next video, have a great time.